All right, well, welcome to Success Physics 101 class. This is chapter 2. Chapter 2, Physics 101 Kinematics, as you can see. The chapter 2 of your physics kinematics. For kinematics, we have chapter 2. And yesterday we did chapter 1, which is systems of measurement systems in physics. And the video was posted for everybody on the online group. So this is chapter 2 now. And we're looking at kinematics today. And on the board here, we have that kinematics is a study of motion without reference to the cause of motion. So kinematics is a study of motion without reference to the cause of motion. So when studying kinematics, we are just studying motion without asking ourselves, why is this body moving? So we don't want to know why the body is moving. We are just concerned that the body is moving. And we'll study what? Under this aspect of physics, we say is what? Kinematics. Kinematics, study of motion without reference to the cause of motion. Now, class, in order to understand kinematics, there are some parameters we use in describing motion of a body. There are some terminologies we commonly use when studying motion. There are some terminologies we commonly use when studying motion. So, having defined kinematics, the next thing we want to go to now is what are the common terminologies when looking at motion? You can't talk about motion without talking about distance or displacement. Distance or displacement of a body. You can also talk about motion without talking about velocity, speed or velocity, speed or velocity. You can't also talk about motion without talking about acceleration of a body. So the first thing we aim to do today is to understand these common terminologies used when studying motion. To understand these common terminologies used when studying motion. Class, why do we have distance or displacement here? Because one is a scalar quantity, the other is a vector. So when defining distance, a distance is the length covered by a body without reference to direction. Length covered by a body without reference to what? Direction. But displacement is the distance covered by a body with respect to what? Direction. So the difference between distance and displacement is that distance gives us not just the distance covered, but distance just gives us the distance covered without direction, while displacement gives us the distance covered with respect to direction. Same thing with speed and velocity. Speed is the measure of how fast a body is moving, but without reference to direction. While velocity is the measure of how fast the body is moving with reference to the what? Direction. So with speed, we are going to know how fast the body is moving, but we will not know the direction the body is moving. But with velocity, we are going to know how fast the body is moving and with the direction the body is moving. Now, when a quantity gives us no direction, we say that quantity is a scalar quantity. And when a quantity gives us direction, we say that quantity is a vector quantity. Clearly, acceleration is a vector quantity. Acceleration is a vector quantity. Now, we have said distance is length covered without reference to direction. Displacement is distance covered with reference to direction. Speed is how fast the body is moving. Velocity is also how fast the body is moving. Now, what then is acceleration? Acceleration is, when talking about distance or displacement, we use S to represent it, S. When talking about speed or velocity, we use U or V. U or what? And when talking about acceleration, we use A. Why do we use U or V for speed or velocity? We use U when we want to talk about the initial, and we use V when we want to talk about the what? Final. We use U when we want to talk about the initial, and we use V when we want to talk about the final. So we say U is initial speed or initial velocity. We say V is final speed or final velocity. And A is acceleration. Class, what then is acceleration? Acceleration is the increase in the speed or velocity of a body per unit time. Acceleration is the increase in speed or velocity per unit time. Per unit. Acceleration is the increase in speed or velocity per unit time. So class, for a body to have accelerated, there must be an increase in the speed or the velocity. This means that a body could be moving but not accelerating. A body could be moving but not what? Accelerating. So for acceleration to occur, there must be an increase in the speed. For acceleration to occur, there must be an increase in the speed of the body. There must be an increase in the speed or velocity of the body. So class, it is possible for a body to be moving, but there is no acceleration. When that happens, it means that the body is moving with a constant speed or constant velocity. Class, if I'm moving quietly like this without changing my speed over time, I am moving but I am not accelerating because my speed is not changing. I'm moving with the same speed. When your speed changes, when you increase the pace, you say speed has changed. That's acceleration has occurred. And class, if increase in speed or velocity is acceleration, there's another term for when there's a decrease in speed or velocity. When there's a decrease in speed or velocity, we say what? Retardation or deceleration has occurred. Retardation or deceleration as, it's called deceleration or retardation. So while increase in speed is acceleration, decrease in the speed is deceleration. Decrease in speed or velocity of a body per unit time. Decrease in speed, deceleration or retardation is the decrease in speed or velocity of a body per unit time. Class, how we know a body has decelerated? The final answer of the acceleration will have a negative value. That will show the deceleration. That will show the what? The deceleration. Now, class, moving forward. We have, in order to properly understand motion, equation of motions. Equation of motion helps us to fully understand motion. There are some equations of motion that have been laid out for us that will help us to deal with our motion problems. So let's look at the equation of motion. Equations of motion. Class, we have 4 standard equations of motion that you can use to deal with problems involving motion. The first one, we have V equals to U plus AT. The second one, we have V square equals to U square plus 2AS. The third one, we have S equals to UT plus half AT square. Fourth one, we have S equals to U plus V all over 2 into bracket T. Or sometimes we could put 1 over 2 U plus VT, right? Sometimes we could put 1 over 2 U plus VT. Class, we are arranging it course chapter by chapter. Let us organize it. We've been learning scatteredly, physics, chemistry. Let us organize. So yesterday we did chapter 1 and I ended chapter 1. Today I must finish chapter 2. When it's time for your class, you just kindly carry your bag and go. I will continue the video. I mean, you continue the rest online. Are we together? I will not stop this video till I'm done with chapter 2. I've set a target to myself. Each day I must cover 1 chapter. I must cover 1. So that by the end of this week, I'll finish physics. Because I planned yesterday was chapter 1, today is chapter 2, tomorrow chapter 3, Thursday chapter 4, Friday chapter 5, Saturday I will do 3 chapters since there's enough time. 3 chapters on Saturday. That will be 8 chapters total this week. And you have just 9 to 10 chapters in your physics. So this week I will have done 8. I'm almost done with the course. Next week I take chemistry like that, 1 to the end. The next other week, further maths. Every day I cover 1. That means in 4 weeks' time, I'm done with your syllabus. In 4 weeks' time, I'm done with your syllabus for at least chemistry, physics, and the 2 maths. Then we can always visit. We can call for biology class. We can call for GS 100 class. We can call for every other course, like engine drawing for engine drawing student, SLT. We can call for other courses. Let us first finish the 4 major. That's because there's the 4 toughest courses that give student problem: chemistry, physics, and those 2 mathematics. Biology is something you can read on your own sometimes. GS is English now, communication skills, but these are the 4 serious. So that's the idea. So any day you're free, come for the physical class. The day you're not free, know that they are recording it for you. Now, moving forward, class. These are the 4 equations of motion. V equals to U plus AT. V square equals to U square plus 2AS. S equals to UT plus half AT square. And S equals to U plus V over 2T. Class, this V stands for final velocity. This U stands for initial velocity. This A stands for acceleration. This T stands for time. Same thing here. The only thing difference is that S is what? Displacement. Distance or displace. So, in order not to be too fast, where V is final velocity, U is initial velocity, A is clearly acceleration, T is time, S is displacement, S is distance or displacement. S is distance or displacement. Now, class, it's one thing to know this equation of motion, it's one thing to know how to use them. It's one thing to know this equation of motion, it's one thing to know how to use them. So very quickly, we'll start taking some key questions under kinematics. Key questions under kinematics. Another thing to also know when to apply equation of motion and when to just say, for example, they give you displacement and time, say find velocity. When do I use equation of motion and when can I say velocity displacement all over time? Class, we all know that without this equation of motion, according to equation of motion, velocity is U plus AT, right? But we also know that generally velocity is displacement all over what? When do I use when can I say distance over time? When must I use V equals to U plus AT? Class, let's take this question down. Physics does not need more story. Straight to question. Straight to what? Class, let me tell you something. If you ask to find the average speed or average velocity, average what? Class, you do not need to use equation of motion. Because equation of motion because the average velocity does not require you to know the initial and the final. Just find the average, the what? That means the average velocity the body covers from point A to point B. What is the average? Plus the average velocity of a body is the total displacement covered by the body divided by the time taken. Total what? Total displacement all over what time? Total displacement all over the time is average velocity. Class, you do not need to use equation of motion yet. So I'll tell you when you should apply equation of motion and when you should just say average velocity, total displacement all over time. Right, and the average velocity of a particle, let's look at average velocity. The average velocity of a particle is defined as the ratio of the total displacement traveled to the total time taken. The average velocity of a particle is defined as the ratio of the total displacement traveled to the total time taken. Is a ratio of the total displacement traveled to the total time taken. Is a ratio of total displacement traveled to the total time taken. Is a ratio of total displacement traveled to the total time taken. So class, when they ask us to find average velocity, we say what? Total distance all over time. Can we have this question? Let's take this question. A car at x1 equals 15 meter. A car at x1 equals 15 meter. A car at x1 equals 15 meter. At t1 equals 5 seconds. At t1 equals 5. A car A car at x1 equals 15 meter at t1 equals 5 seconds. A car at x1 equals 15 meter at t1 equals 5 is later seen at x2 equals 20 meter at t2 equals 10 seconds. Find the displacement and average velocity of the car. Find the displacement and average velocity of the car. Find the displacement and average velocity of the car. Question 1. Question 2. A particle has an average velocity of 108 kilometer per hour. A particle has an average velocity of 108 kilometer per. How far does it travel in time interval of 1 minute? How far does it travel in time interval of 1 minute? Class, if you look at this question carefully, these two questions, you will see that they are not questions that require you to use the equation of motion. They are not questions that require you to use the equation of motion. Because you will not see anything like a body starts from rest. Class, the language of the question will start telling you, oh, rest, U is 0, right? You already know that you are dealing with equation of. But this one, you will not see anything like a body starts from rest, then comes to rest, or have a velocity. You understand? So the language of the question will tell you, should I just use normal velocity displacement over time, or should I use equation of. Class, these two questions on the board have no business with equation of motion. They have no business with equation of what? Motion. Question 3. I believe we are done writing this first two. Question 3. Please, if you are following this class online, if you want to be a good online student, you should have a writing material. Don't just watch it as if you are watching skits. You're not watching skits, you are learning. Be at your reading table, your reading desk. Remove all distractions from you. Take a writing material and a book, and you are in a class. You miss the class, so you are taking the class. Take away all distractions from you, off your TV, off everything, and focus and study. Let this be your study time. So don't just say, just sit down and be watching it. You don't understand it like that. You see, we are taking questions. And I'm personally writing these questions on the board. If I was teaching just the physical class, I can dictate. But I'm personally writing it on the board so that in case I'm too fast with dictation, you can follow up. So please, you have your writing material. You want to start if you like, have your writing material and a book, a clear book, your calculator. So you'll be solving the examples. And if you have any question, you can drop your question in the comment. The comment is open for this video. Drop your questions there in the comment section so that we can answer you as well. If you have any questions, how did you solve number 1? We'll answer you. So please have your writing materials. If you know your writing material and you have been watching, go and get your writing material now and your pen, your book, and come back, pause the video, come back, and continue learning with the class. Thank you. Now, question Question 3. How long will it take a car? How long will it take a car? Question 3. How long will it take a car with average velocity? You see, all this question, average velocity. No, that you're not dealing with that. You're not using equation of motion. 240 kilometer per hour to cover a displacement of 20 kilometer. Answer must be in seconds. Answer must be in what? Class, in physics, they don't need to say find the time taken before they say find time. If someone say how long, it means time. It means what? There are some common phrases that are used in physics. How long is time? Class, how far is what? How far means distance or displays. So they say how far does a body cover? Distance or displacement. How fast? How fast is speed? How fast is what? Speed or velocity. Speed or what? Velocity. So please take note that it could be asked questions in motion without telling you the quantity involved. They'll just use a particular phrase. Class, we have 3 questions to solve. How far is distance or displacement? Yes. How far is distance or displacement? All right. So welcome back to Physics 101 Kinematics class. And we have some questions that we want to solve right now. And we'll start taking the questions immediately. So in the previous video, we listed out 3 questions on kinematics. And we're about solving them. And these questions, why we brought out these questions is because these questions should not be solved with the equation of motion. They cannot be solved with the equation of motion. You just solve them with normal knowledge of average velocity equals total displacement all over time. And that's what we're about to show you now. And we're going to start from the first question. We're going to start from the first question. Those just coming in here, lucky. We have not solved even one example yet. We just did introduction. So this is chapter 2, kinematics, chapter 2. Now, let's take the first question. Let us take the first question. I believe we have the questions in our notes. If you're online, the former video has the first question. If we are told that a car at x1 equals, if you're just coming in, collect the question from someone beside you. A car at x1 equals 15 meters at t1 equals 5 seconds is later seen at x2 equals 20 meters at t2 equals 10 seconds. This is chapter 2, physics 101, kinematics. And we have said kinematics is the study of motion without reference to the cause of motion. Class, the average velocity of this body, V average, the average velocity is going to be x2 minus x1, because actually if you want to do, you say it's change in displacement all over the change in the what time. Average velocity. Change in the displacement all over the change in the what time. The change in displacement is the final displacement x2 minus initial displacement x1. So in this question, the body was first found at x1, 15 meters. This is the initial displacement of the body. Later found that x2 equals 20 meter final. Also initial time, final time. So class, our average velocity for this kind of question, you will not use equation of motion. We're going to say change in displacement over change in time, which is x2 minus x1 all over t2 minus t. So which is x2 is 20 meters minus x1 15 all over t2 10 seconds minus t1 5. So 20 meter minus 15 meter is 5 meters. And 10 seconds minus 5 seconds is 5. 5 divided by 5 will give us 1 meter per seconds. 1 meter per seconds. Yes. This is how we solve the first question that was given. Let us write fast. Let us write fast. Class, moving on. Second question said, a particle has an average velocity of 108. So class, this one they're giving us the average velocity. A particle has an average velocity of 108 kilometer per hour. How far does it travel in a time interval of 1 minute? Class, in a time interval of 1 minute, a particle has an average velocity of 108 kilometer per hour. A particle has an average velocity of 108 kilometer per hour. How far does it travel in a time interval of 1 minute? Class, the first thing we have to do to this is that this guy must go to what? This guy must be converted to seconds. This guy must be converted to meter per seconds. Class, how far means displacement? Displace. The question said how far? Displacement. We know the average velocity equals total displacement all over time interval of 1 minute. Class, 1 minute is equivalent to 60 seconds. Are we correct? We must change this kilometer per hour to meter per second. And there's a shortcut. Just multiply by 1,000 and divide by 3,006. Class, when going from kilometer per hour to meter per seconds, simply multiply by 1,000 and divide by 3,600. Simply multiply by 1,000 and divide by 3,600. Multiply by 1,000, divide by 3,600. That's how you go from kilometer per hour to meter per. Please, I think what we're going to have, we do that, if we do the math well. So 108 times 1,000 divided by 3,600 looks like 30. 30? So we have 30 meter per seconds. 30 meter per seconds. Class, our average velocity is 930 meter per seconds. Our time is 60 seconds. We are looking for displacement. Class, if average velocity is displacement all over time, can we make displacement sort of formula? Cross multiply. So our displacement is velocity, average velocity times time. Do you agree? The total displacement is average velocity all over time. Class, what will be the unit we'll get average velocity in? Will it be in kilometer or meter? To be in meter. To be in meter. Why? Because our speed has been converted to 30 meter per hour. And our time is in seconds. So our final displacement will be in meter. So that will be 30, look at 30 meter per seconds multiplied by 60. Because time is 60 seconds, right? Average velocity is 30 meter per. Can seconds cancel seconds? What's left? Meter. Are you saying? 30 times 60 gives you what? 3 times 8, 6, 18. 1,800 meters. So class, the displacement covered by this body is 1,800 meters. The displacement covered by this body is 1,800 meters. Now let's write fast. Remember that we can't be wasting much time. The third question now. The third question said we should find how long will it take a car? How long will it take a car with average velocity of 240 kilometer per hour to cover a displacement of 20 kilometer? Class, average velocity is 240 kilometer per hour. To cover a displacement of 20 kilometer, class, displacement is 20 kilometer. The displacement is 20 kilometer. How long means what? Time. How long means time. They said, how long will it take a car with average velocity of 240 km per hour to cover a distance of 20 km? Class, if we do not convert and we use this like this, our time will be in what? Hours. If we do not convert anything and we leave it like this, our time will be in what? Hours. But your exam is objective, so you will now find out, are my options in objective or are we together or theory? Or maybe it's subjective. If it's an objective, check your options. Is it in hour or seconds? You know whether it's convert or not. Class, let's assume that we are to leave our answer in hours. It means we are not converting any of this. Class, average velocity displacement all over time, right? We want to make time subject to the formula. Time must be displacement all over average. Time should come up, velocity should come down. They will just exchange positions. They will exchange. Time comes up, velocity comes. We're making the time subject to the formula. So displacement is 20. Average velocity is 240. 20 divided by 240. What's 20 divided by 240? Someone should help us. 20 divided by 240 is not 12. Now it's 240 divided by 12. That is 20, that is 12. 0.0083 hours. Class, 0.083 is the time taken. Is the time taken. 0.083 hours is the time taken. You see? If your answer to be in seconds, you then multiply by 3,600. To convert to seconds, multiply by what? After getting your answer in hours, from hours to second, multiply by 3,006. So what is 0.083 multiplied by 3,600? 299.9 seconds, which is approximately what? 300 seconds. 299.9, approximately 300 seconds. Class, that's the aspect of what? Of kinematics that does not require equation of motion. Let's now go to the aspect of kinematics that requires you to use your equation of motion. Let's go to the aspect of kinematics that requires you to use your what? Equation of motion. Let's have this question. Let us have this question. A body starts from rest and accelerates uniformly in a straight line. A body starts from rest and accelerates uniformly in a straight line until it reaches a velocity of 40 meter per seconds in 8 seconds. In 8, it then travels uniformly for 12 seconds, after which it is uniformly retarded and brought to rest in 5 seconds. And brought to in 5. Calculates I, the acceleration. The what? I, the retardation. I, the total distance covered. The total distance covered. A body starts on rest and accelerates uniformly in a straight line until it reaches a velocity of 40 meters per hour in 8 seconds. It then travels uniformly for 12, after which it is uniformly retarded and brought to rest in 5 seconds. Calculate I, the acceleration, I, the retardation, I, the total distance covered. Class, let us be fast. Class, let us be fast. Let us be fast. This place I'm standing, am I showing the video very well? It's cutting me into half. What of this? No, leave it. Don't shift it. Leave it. The board is more important. So, eh? Please let us be fast. Hello? Hello? Yes, please straight to the points on the line. Oh, yes. What do you need? Hello? Hello? Please come to PS class 7. I'm in PS class 7, please. Yes. Yes, 6 or 7. Check one of them, you see me. Class, you are done writing now? Yes. Class, a body starts from rest means U is 0. U is what? Initial velocity is 0 meter per hour. And accelerates uniformly in a straight line until it reaches a velocity. V is 40 meter per seconds. In time, 8 seconds. Class, this is the first stage. First, because this body, as the story is long. A body starts on rest and accelerates uniformly in a straight line until it reaches a velocity of 40 meters per second. Time 8 seconds. Class, it accelerates, right? So this is the part of the question where it accelerates. Let us assume this is a velocity time graph. And a body starts from rest and accelerates uniformly in a straight line. So from 0, it reaches a velocity of 40 meters per second in 8 seconds. In what? So this time from 0, 8 seconds. It then travels uniform, means that it did not change, it did not increase speed again. It travels what? I mean, it did not keep increasing speed. It maintained that 40. It then travels uniformly for 12 seconds. 8 plus 12, it means extra 12 seconds will give us, that's 20. So the interval between this point and this point is what? 12 seconds. That's why 8 plus 12 is what? So it first travels 0 to 8 seconds, then 8 plus under 12. So this will land at 20, right? You cannot write 12 here. That means 8 minus 12 is 4 seconds. So it's add 12 to make it 20. Now, after which is uniformly retarded means it comes down, right? After which is uniformly what? Retarded. In how many seconds? So 20 plus, so the interval between this point and this point is 5. Is what? That's 20. So between 0 to 8 is 8 seconds. This is the first stage. This is the first stage of motion of the body. This is the second stage, and this is the third stage. So it is brought to rest, means it comes back to 0 in 5. At the end of the question, it's brought to rest in 5 seconds. Calculate the acceleration. Class, where was the acceleration? This was where there was acceleration. Calculate the retardation. Where was the retardation? This was where there was retardation means it came down, right? It reduced speed. Acceleration, when it's increased speed, this was where it increased speed. When it reduced speed, this was where it reduced. And the third one, total distance covered by the entire motion. Class, first things first, this is a velocity time graph. And class, you could be asked in the exam, the slope of a velocity time graph represents what? Class, the slope of a velocity time graph, please note, it's a common exam question. The slope of a velocity time graph represents acceleration. Represents what? The slope of a velocity time graph represents the acceleration of the body. Because class, if this is velocity to plot a graph of velocity against time, if you have to check the slope, what will be the slope? Change in velocity all over change in the, remember, that if you're looking for slope, it is change in the y-axis all over change in the x. And what's velocity divided by time? It's an acceleration. So you see that the slope of a velocity time graph gives what? Acceleration. Now, also, you could be asked in the exam, the total surface area covered by a velocity time graph represents the displacement. Total surface area of a velocity time graph represents what? Displacement. Is the displacement. Class, the slope of a velocity time graph represents acceleration, but the total surface area of a velocity time graph represents displacement. Please take notes. I will explain it. I'm not done. The total surface area of this graph, class, you are going to take the whole graph. This graph is a trapezium. I will come there. I'm coming one after the. But just to tell you now, the slope of a velocity time graph is acceleration, and total surface area of a velocity time graph is displacement. Now, class, let us now solve the question. Class, the first part is the what happened in the acceleration part, class. So we have you in the first part of motion, the body started from rest, then accelerates until it gets to a velocity of 40, right? So final velocity is 40 in 8 seconds. Let's find acceleration. Class, we have 4 equations of motion, which I've said before, but I'll show it again. V equals to U plus 8t. V square equals to U square plus 2as. S equals to UT plus half AT square. and S equals to U plus V all over 2 into bracket C. Question we'll ask ourselves now. This is clearly a question that requires equation of motion. What equation of motion will be able to tackle this exact question? Which equation of motion is best for this question? The first one can easily deal with it, right? The first one can easily deal with it. So we'll just say V equals to U plus AT. V equals to U plus what? So V class equals to, who is U? 0. Plus A is what we are looking for, right? Who is T? 8. Oh, we even know who is V. So who is V? 40. So 40 equals to 0 plus A into bracket 8. So 40 equals to, this 0 can go 8 times A, 8. Can we divide both side by 8? To make A subject of the, so that A is 40 all over 8. 40 divided by 8 is 5 meter per second square. 40 divided by 8 is 5 meter per second square. Class. We have answered the first part of the question, say find acceleration, right? The second part now said we should find retardation. Class, this is where there's retardation. Class, don't be surprised in our retardation, we have a negative answer. Don't be surprised. Because retardation means decrease in velocity, right? It usually comes with a negative answer. I don't think you are wrong. If you get a negative answer, you are not wrong. To get the retardation, we could still use this same V equals to U plus 80. Because A represents both acceleration or retardation. Class, are we done writing this? Okay, so let me clean. Let me clean. Now, to get the retardation, we must ask ourselves, what is the retardation happens in the third stage, right? In the third stage of motion of the body. Class, in the third stage, initial velocity is coming down from 40 meter per seconds to 0. Final is what? 0 meter per. It comes to rest, right? In the third stage. So U is 40 meter per seconds. V is what? 0 meter per seconds. In time, how many seconds? 5 seconds. The last stage of motion covers 5 seconds. We are looking for the retardation. Class, A represents both acceleration and retardation, right? But just that one is positive, one is negative. Class, we are still going to use V equals to U plus AT. We are still going to use V equals to U plus AT. So we are going to say, who is our V now? 0. Who is our U? 40. We don't know our A. That's retardation we are looking for. And our T is 5. So we are going to say 5 times A is 5A. So 0 equals to 40 plus 5A. Can plus 5A come to this side? It becomes minus 5A equals to 40. Let's divide both sides by minus 5. So that 40 over minus 5 is minus 8 meter per second square. Class, are we surprised by the negative answer? No. Because in deceleration or retardation, we expect a negative because there's a decrease in speed from 40 to 0. Let us be fast, please. Let us be fast, yes. The 12 seconds is what happens between here and here. There was no retardation here. This was where there was, between the 12 seconds, the body was moving at constant. Listen to the question. It was moving at constant was uniformly. This was where it started coming down. So we have no business what happens in this 12-second interval. But class, the total distance covered by the body, we have business with everything the body did from 0 to 25. It's clear that the body spent 25 seconds in the total, all the stages of motion of this body. It was from 0 to 25 seconds. So it went up, moved uniformly, and came down. Class, We need to find total distance covered by this body. There are two ways of doing it, class. We can find, I told you that the total distance covered by a, to get it, the total surface area of a velocity time graph gives the total displacement or total distance covered. Class, if I find the area of this is a trapezoid. Let us bring out the shape of this graph out. You see that this is the shape of the graph. Watch. This is this graph. This. And this is a trapezium. We have A, we have B, and we have height of the trapezium H. Class, the area of a trapezium is 1 over 2 A plus B into bracket H. If I find the area of this trapezium, I've gotten the total distance covered. Class, I will find the area of this trapezium and I will get the total distance covered. And I also use normal motion, equation of motion, and we'll have the same answer. To tell you that the total distance, the total surface area of a velocity time graph gives the acceleration. So I will look for total surface area of this graph. Class, it's not every time your graph will be trapezium. It depends on how the body was moving. If you are told that a body started from rest and then moved 30 meters per second and then comes back to rest. Class, what is total surface area of this? This is a triangle. So it depends on the motion. The motion of this body gave a trapezium shape because it first accelerated uniform 40 meters per second, then did not increase speed, then came. But this one, they say a body started from rest and then accelerated till it got to, let us say 50 meters per second, 50 meters per, then it decelerated down completely. This one will be half base times height. Half base times what? Area of a triangle, half base times. So the shape of the graph is not fixed, class. Don't say it's always going to be trapezoid. Let me just cram this formula. No. It's your job as a physicist to be able to bring out graphically what happens in motion. But thank God your exam is OBJ, so you don't even need to show this graph. You can use the equation of motion to get the answer. But remember that this course comes with a 30 mark CA test. Your exam is 70 marks, but there's going to be a CA they'll set for you close to exam. Because whatever you're doing in your phys practical does not affect this course. So don't think that phys practical is your CA for this course. No, that one is a course on it. So this physics course has its own CA. Now, class, what's A? A is what happened between this point and this point. This point and this point, what happened? 12 seconds. Now, B is what happens between this point and this point, which is 25. Height, what's the highest point attained by this body? 40. 0 to, this line is parallel to this line. So whatever is this to this is this to 40. Class, we have 12, 25, and 40. So half into bracket. Remember that half A plus B times height is the area. Is the what? Area. Half, what's A? 12. What's B? What is our height? 12 plus 25. Half of 40 is 20. Half of 40 is 12 plus 25 looks at 37. 37 times 20 gives you 740. Someone should confirm. I'm using my head. What's 37 times 20? Correct? 740 meters. Total displacement covered by the body. Displacement. By just using the area of the what? Trapezium. This is shorter. But let me show you the longer method where you have to find the distance covered in this first stage plus distance covered in the second stage plus distance covered in the third. We'll give you the total distance covered. If you don't want to use this, my approach, class. Let me tell you. So, class, I can divide this body into 3 stages. The first stage is a triangle, class. The second stage is a rectangle, and the third stage is another triangle. Class, this is the first stage. This is not a triangle, right angled. This stage, from this stage to this 12 is rectangle, and this last stage is another triangle. Class, this first stage was 0 to 8 seconds, right? So this is 8, the base, this is the base of the triangle, 8. The height was from 0, on the vertical axis is 40. Is what? Now, coming to this side, this length is 12. This is what? 12. And this height is what? 40. Coming to this side, this height is still 40. Because this side is 40. And this width is 5. Is what? Because between here and here is 5, right? If I find the area of this plus the area of this plus the area of this, I'll still land at 740. I'll still land at what? This is a triangle, half base times height. Area of a triangle is half base times. The base is 8. The base is what? Half times 8. What's the height? Half of 8 is 4. 4 times 40, 160. So this body covered 160 meters in the first stage. It's even good I'm showing you this because they could have asked you, what's the distance covered by the body in the first stage of motion or second stage or third? In the first stage, you cover one. Second stage, what's the area of a rectangle? Length times 40 times 120 is 480. Is 480 meters covered in second stage. Third stage, half base times height. Base is 5, height is 40. Half base is 5, height is 5 times 40 is 200. 200 divided by 2 is on. Class, it covered 160 meter in the first stage of motion, covered 480 meter in the second, and covered 100 meter in the third. 160 plus 480 plus 100, you find out that it's 740. Physics does not lie. If you are good, you are good. You know, no matter how you find, you get to the same point. Now, Chairman, how far? I don't see them. Even was it Sunday? We sit down together on Sunday.
But this man come back this year. This come back this year. The warrior, and I have
I will call him. I don't see him.
you say I'm really content with today. Say you never see him.
Call him. I don't see him. Just call him for phone. Now, another question. A body moving in a straight line. A body moving in a straight line. A body with an acceleration, moving with a straight line with an acceleration of 12 meters per second square, has a velocity of 80 meters per second after 5 seconds. Find the initial velocity of the body and the distance covered in the 9th second. And the distance covered in the 9th second. A body moving in a straight line with an acceleration of 12 meters per second square has a velocity of 80 meters per second after 5 seconds. Find the initial velocity of the body and the distance covered in the 9th second. Please write down quickly. A body moving in a straight line with an acceleration of 12 meters per, acceleration is 12 meters per second square, has a velocity of 80 meter per second after 5. Find the initial velocity. Means that this 80 meter per second is the final. Find the initial velocity u after time t is what? 5 seconds. And the distance covered in the 9th second. And the distance covered in the 9th second. Class, initial velocity u, we can use the normal equation of motion v equals to u plus at, right? Our v is 80. Our u we don't know. Our a is 12. Our t is 5, right? 80 equals to u plus 12 times 5, 60. Can we make use of the formula? Bring 60 to this side. 80 is already here. When 60 comes here, it becomes 1 minus equals to u. 80 minus 60, what's u? 20 meter per. So class, our initial velocity is 20 meter per second. This is the easy part of the question. The hard part is the distance covered in the 9th second. The distance covered in the 9th second. The distance covered in the 9th second. Write this down so we can do the second one. What do you need? Oh, you want to attend the tutorial? Okay. No, I don't. I just want to register. Yeah, let's register you. So the subject is doing 3 subjects. What are they? What's the department? We're doing 2 maths. Yes. Total is 12 for everything. 12 for everything. Okay, that's good. Let's register. I've registered your colleagues already. Yeah, well, are you your card? There's a PS, so you can get your receipts. Okay, you can transfer. That's what you did. Be fast, please. I'm in the class. I'm recording, so that's the account number there. Go to the back there. Class, what's the distance covered in the 9th second? Permit me to clean this. Class, they did not say find distance covered in 9 seconds, so please, distance covered in the 9th second, class. I must explain something to you here carefully. We have from 0 seconds to 1 seconds, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8, 8 to... Class, the first second of motion of a body is between 0 and 1 second. The first second is achieved. Second second is between 1 and 2. Third second between 2 and... This fourth second, fifth second, sixth second, seventh second, eighth second, ninth. So the 9th second between 8 and 9. Class, to find distance for that means the distance between this interval between 8 and 9 only is the 9th second. Now we don't want to know what happened in all this, but between 8 and, but to do that, we must first get distance from 0 to 8 and get distance from 0 to 9. Class, this small space between this and this is the 9th second. Class, we'll find the distance from 0 to 8. So we'll find distance in 8 seconds. And from 0 to 9, distance in 9. And 9 minus 8 will give us the gap, this little gap, right? The 9th. Distance covered in 9 seconds minus distance covered in 8 seconds will give us the distance covered in this 9th second. Now, in this 9th second, that's distance covered in 9 seconds minus distance covered in 8 seconds will give us distance covered in this 9th second. Now, let us find distance covered in 9 seconds. S equals to ut plus half at square. We'll find distance covered in 9 seconds. It means that our time here will be 9. Don't forget our u is 20. We got u as 20 times time 9 plus half. What's our a? 12. 9 square 9. 20 times 9 is 180. Half of 12 is 6. 9 square is 50. 9 times 9, 80. 180 plus 6 times 81 is what? Someone should help me, please. What is 6 times 81? What's 6 times 81? 486. What's 180 plus 486? 666.